Okay, you got me. Okay. I know I said I was going to do video on this a while back. Hold on. Okay. So, I know I said a while back that I was going to make a video talking about the programming of fire alarm systems. So, I did one video previously, and then I tried to do this one, and I tried to do it multiple times, but each time I was just like, I wasn't happy with that part. So now this will just be completely unfiltered, just from what I know. So programming fire alarm systems, you know, in some cases can make or break your system. So like I've seen people leave comments about Gamewell E3s. They say that they've come to realize that programming can make or break them. If you've got good programming, they are solid, but if you've got bad programming, they are giant pieces of garbage. And I understand, you know, I've seen both sides of it. I've seen systems that work really well and systems that don't work so well. And it makes, you know, Siemens and Simplex look superior, which in, you know, in retrospect, they are. But, so, yeah. I mean, if you can graduate from Honeywell, then yeah. But, so basically programming, and especially on addressable systems, is a very good skill to have. It's a great skill to have. Because, you know, you get a lot more intuitive on your understanding of fire alarm systems. So like you understand like exactly what does what. So like your SLC is going to have your pull stations, your smoke detectors, your relay modules, some control modules, also known as NAC modules. And those can all be configured. And if you wanted to set an address on a monitor module to just do like a, you know, like say you set 9 to a pull station, you could set that monitor module to 9. It doesn't have to be, you know, an addressable pull station. You know, you can use any regular monitor module for that and it will work. It absolutely does not have to be a pull station. You can just use that as like a designator, so to speak. So that's one thing that's nice about these systems, and typically, you know, stuff like that, you know, would be viewed by some people as a flaw, as like, oh, they use the same design for everything. Like with elevators, for example, I know a lot of manufacturers, but the one I'm going to talk about right now is called US Elevator. They made their buttons and their floor indicators use the same housings, to where like the floor indicators, you know, those, you know, the the part with the number on it, if you're tall enough to reach, you could actually touch it and it would press like a button. You know, just because, you know, they don't want to have to, you know, come up with a new design for something like that. You know, it just uses the same thing. It's kind of like that. And you know, that all goes into simplicity, because simplicity is nice. You know, why make something complicated if it doesn't have to be? You know, if you want something complicated, go buy a BMW. Okay, that's all I'm gonna say. But most of programming involves grouping and mapping. So I'll talk about grouping. So on addressable systems, you'll have your input zones, which, you know, are crucial for conventional systems. And then you've got your output groups, and you have to map your input zones to your output groups. So you might think, oh, what's the purpose of having zones on conventional or addressable? Well, zones keep you from having to map each individual device to an output group. You know, say you got a big system, 50 devices, you don't want to have to, hit like 50 different check marks. You know, you can group those into the group that you need, and then, you map that to whatever you want it to activate. So let's say a warehouse, for example. So you'll have your one means of manual activation. That'll be your general alarm. And then you'll have your water flow switches, which will be your water flow signals. And then let's say this is a municipality that requires a horn strobe and a bell. So the, excuse me, oh goodness. So the pull station and the smoke above the panel, which will both be there, you would just want to activate general alarm. So you could set that to zone 1, and then you'd have to map that with group 125 is how it is for most cases. So, and for E3s, for Gamewell, they actually call the input zones input groups. So if I say input groups a couple times, that's just out of habit. But yeah, there's a little bit to it, but I'll try and explain the basics as best as I can without making it too complicated. So basically, you can view it like, you can think of it like a spreadsheet. So like you'll have your output groups and then your input zones. And another way that you could refer to it is like a system operating matrix. You'll have your input signals over here and then actuating signals right here, or input devices here rather, and then actuating signals. So like you'd have area pull stations, area smoke detectors, duct smoke detectors, water flow switch, tamper switch, stuff like that. And that's a bit of how mapping is done. So for HFSS and SKSS, for the Fahrenheit and Silent Night lines of panels, which by the way, Fahrenheit is just Silent Night. It's literally just Silent Night. So, you can call a Fahrenheit panel a Silent Night panel. It's the exact same thing. The only thing that's different is the software. So, yeah. But for those softwares, yeah, it's just a matter of, you taking your input group and, lining it up with, like group 124 or 125. So like in SKSS, it's very intuitive. Like you can choose what each thing does. Like, okay, can the manual pull on this zone activate this output? And like with my 5700, it would be the exact same thing. So like, can manual pull activate this? No. Can water flow activate this? No. In my case, I have supervisory is able to activate it for my alert strobe for the M&S, which is my mass notification system, even though it's only one speaker. But I have that mapped in that specific way to do that. And then when it comes to Gamewell, you're looking at stuff that's called, you're looking at something called CAMs. And CAM is short for conditional action message. So similar to an Excel spreadsheet, you've got your input groups. So, like say, warehouse, you want activate group 125, you set group 125, you can group NACs to, output groups. You can assign them a network group, and the lowest you can go is 125, and then the highest that you can go, I believe, is 200, and then it goes from 400 to 599, I believe. Don't quote me on that. But basically, it's not check marks and stuff. It's not checking boxes. In CamWorks, it's a little different. So if you want your zone 1, or in this case group 1, to activate your general alarm NAC with your horn strobes, you would have to type something called a cam expression into the box for the line for group 125. What you would type in that box would be N1G1, which is node 1 group 1, or if it's a standalone system, it would be node 0 group 1. So N0G1, and if you want it to be silenceable, you would put and not node 0 group 400, which is not when silenced. And then if you had bypasses, you would map that to your bypass button, which in this case, since you can't add any cam expressions to a regular cam above group 447, you'd have to use something called a scratch pad, which starts at group 416, so you'd be safe there. So then you more than likely use group 416, node 1 group 416. So your full expression is going to be node 0 group 1 and not node 0 group 400 or node 0 group 416. And you could type that all out, you know, type out the word and not. You can type out or, and then it'll automatically put the symbols in there for you once you hit enter. Now for water flow, mapping that, and this is where I say that CamWorks is easier to use than the Honeywell Fire Suite or even SKSS. So say group 126 is your water bell, and by code that cannot be silenceable. You don't want that to turn off when you press silence on the panel, only when you press reset and when the alarm condition has been restored to normal. So the way you would do that is you would type node 0 group 2 and not, when bypassed, which you could use node 1 group or node 0 group 416 for that as well. You could even have that on the same button and just do like a NAC bypass, or I call it a NAC disarm, just because, it makes sense. You could do NAC disable, bypass, disarm. Disarm makes the most sense to me, so that's the one that I typically use. But yeah, so for group 126, you would leave out the node 0 group 400 because you don't want it to be silenceable. So that's kind of the deal with that. And now with, I'm going to go into AutoCall and Simplex ES. So there's no really like assigning groups or zones or anything like that with that one. So with that one, there is your device types. Whenever you set the device type, it automatically puts it into a list. And those are auto-generated. So like whenever you set something to WSO or water flow alarm or tamper, it's automatically put into either water flow alarm monitor list or a sprinkler supervisory monitor list. And whenever you do your disarms for that, you can reference those lists and just completely disable those points. And if you want to leave certain ones out, then you'd have to make an extra list, which will start you at list 256. But yeah, there's a little bit to it. I'd say the AutoCall ES is definitely the most tedious that's out there, but once you learn it, and after many phone calls with tech support, many hours of talking to them, you will start to learn. You know, especially if you have a supervisor or you're asking questions, trying to get help, and they're like, okay, I'm gonna have you do this, all right? Get out a notepad. Get out a pen. Put the pen in your hand. Now you put the pen to the paper. Okay? I've heard of stories, people doing stuff like that, you know, to get their helpers to learn. And believe me, you will learn, you know, because you have to, because you want to avoid that confrontation. But I mean, these days you won't really see that as much. But yeah, so programming, you know, there is a special skill set that's required in order to do programming. And hopefully it's your job and you don't have to leave that job and then go to another one if it's like right before a final. Because, and hopefully you're pre-testing. If you're not pre-testing, you are just facing the shadow of death right there, because pre-tests are not only policy, they're required by code and by law. You are required by law to pre-test, okay? If you don't pre-test, you are looking for all kinds of trouble. All right, and if the fire marshal finds out you didn't pre-test, which it won't be hard for him to figure out, they can report you to the state fire marshal, and if they figure out you've done it before, they can suspend your license for 2 years and stuff like that. And then if someone gets hurt because of it, you could be suspended even longer and then get fined like $2 grand. So that's not something that you want. So like once you start like, you know, getting into like specific programming, like stuff like experiment wise, like start experimenting with stuff, that's when you have to pre-test everything. You know, even the little things, even the little extra things that you added, okay? Because people like their gimmicks, all right? People like their gimmicks and they like them to work, all right? They want their NAC disarm to work. They want their sprinkler disarm to work, and they want their RTU bypass to work, okay? And if it doesn't work, then somebody is not gonna have a good day, because most of that stuff, most of the time, is not able to be configured from the front of the panel. You absolutely have to have a laptop to do it. So, you know, hopefully, if it's your job, you're the one that's doing the programming. If it's not, you know, I would make sure, I would see if you can stay back for doing the pre-test. You know, see if there's anything that needs to be fixed. And then you can just do it right there, right then. So, I mean, there is quite a bit. But, you know, once you learn a couple different softwares, then it's just like, oh, okay. And I've even heard with Edwards, once you get into mapping, like mapping with Edwards is a whole different animal. Apparently, their mapping is so good, you can go in there and you'll be finding ground faults faster than dispatch can get your service guy out. Like that's how fast you can find ground faults on Edwards, from what I hear, okay? So anyways, that's it. I'm done with this. I think this one came out pretty good. If y'all have any questions or anything that I didn't think of, leave me a comment below. I'm always happy to see what y'all have to say, see what y'all want to hear. And I am an open book, okay? I'm still learning new stuff every day. All right? So, I'll talk to y'all soon.